Well, this is my session. Everything you know about isolation levels is wrong. There are a few people in here who maybe are less wrong than others. You, not you, maybe you. Yeah, you're all right. All right. So the funny thing about this session is that is the title. That's the working title. And it is honest, but if we're going to be really honest, the title of this session really should have been Read Committed is a Crappy Isolation Level. I didn't think I could sneak that one past the program committee, so I had to do this. Everything you know about isolation levels is wrong. Really kind of a dark horse session for why you should probably be using an optimistic isolation level and not complaining. All right. Let's do a little bit of scrolling here. My name is Eric Darling. I am a SQL Server consultant. I have very, very reasonable rates. If you would like to, oh, you know what? We're having that fun thing where Zoomit tells me it's going to start at startup, but then at startup, Zoomit doesn't start up. So you get to see the entire contents of my computer. And this is live streaming, which is a really good sign. And we're going to go into Zoomit 64.exe, which is hopefully not a weird piece of spyware. And now everything will work. Wonderful. So let us commence with the zooming. If you would like to get in touch with me, these are the best ways to do that. I am on all sorts of social medias. Just pay very close attention to the contact information. My name is Eric with a K, not Eric with a C. If you start talking to someone on the internet whose name is Eric with a C, there is a very good chance that they are some sort of sociopath or serial killer because their parents did not love them enough to spell their name right. So be very careful. They're dangerous people. Just don't meet up with them. You are being catfished or something awful will happen to you. If you want to download the demos or the database for this, those are the links to do it. I'll put them on my blog at some point when I have time and I sober up or something. We'll see when that is. I don't know. But just keep an eye on that if you care about that sort of thing. I want everyone to just take a moment to see that I'm wearing my dark mode SQL Server Management Studio shirt. When Erin Stellato, my dear friend, when she gave me this shirt, she said, you've been a little hard on SSMS lately on the internet. And I was like, no, what did I do? And then she brought up a couple things. She wasn't wrong, but look, none of us would be here where we are without SSMS. So I can't be. I forgive the little grudges. There are some things that would be nice if it were in there, like commas or some decent GUIs and things like that. But it's okay. We're okay. What I'm most excited about on this shirt, if you take a look at it, is obviously not the Copilot thing. I am excited that SQL Server Management Studio is finally old enough to drink, because it has been working with SQL Server for so long. Boy, it deserves one. So I just want everyone, including Erin, to know I hold no beef with SSMS. So let's get going. Does anyone know what this symbol is? Room full of dorks. Come on, someone say it. The Flash, that's right. For the duration of this presentation, you are to pretend that I am the Flash. You ever seen Flash movies or TV shows or whatever? What does the Flash do? The Flash moves so fast that time slows down around the Flash. And he does all sorts of cheeky things, put bad guys in front of things that are going to explode and save babies and slap butts and stuff, right? The Flash does all sorts of things, and he never gets caught because he's that fast. You are to pretend that I am the Flash, because I do not have Flash-like abilities, nor do I have enough arms or computers to really simulate highly concurrent workload stuff. So you're just going to have to pretend that when I do stuff like begin a transaction and start talking and do some stuff over here, that I am moving in hundreds of milliseconds, and everything is happening very quickly, which is how things happen on your servers and in your applications, all right? So just remember that. When I'm doing these things, that I am moving at Flash speed. So we're going to talk about, first, something that surprises a lot of people about read committed, the garbage isolation level, all right? So we have query plans turned on through the magic of Control and M, and we are going to run this query right here, and we're going to look at the query plan. This should take about 4 or 5 seconds. And something that I want to say, because I see Hugo sitting down in front, this is not a query tuning session. This is an isolation level session. We're not going to make this thing faster, all right? We don't need that, okay? We're not doing that here. You're good, all right. Just making sure. You start asking me what indexes are and telling me you think we could fix it. I know. All right, okay. I forgive you preemptively. All right, let's zoom in on this thing. So the first thing that this query plan does is scan a clustered index. I know. Scan a clustered index, sorry. Then we sort some data. And that part of the query plan comes from this part of the query in here. Let me unhighlight that so it looks a little more professional. That part of the query plan comes from this part of the query, okay? So in the query plan, this part of the query executes first. After that part of the query runs in the query plan, we do a little index seek into posts, and this is where we find those matching parent IDs that we care about, and then we do a key lookup to find the rest of the rows that we're selecting. All right, so in order, scan a clustered index, sort some data, join back to the table to find the parent IDs we care about, then do a key lookup to find all the columns we care about. Everything's going swimmingly, isn't it? This is all grand stuff so far. Not a single mention of an isolation level yet. We're doing great. So let's stick this into a window. And I've got some protective spells in here because rehearsing isolation level demos is a lot harder than it looks. And you have some weird things that can happen. So we're going to put that in this window. And then we're going to put this in a third window. And it's going to be really fun watching me copy and paste things. All right. So, yeah, we did it. We did it. Thank you. Thank you, thank you, thank you. Okay, so here's what's going to happen. Here's where I am officially the Flash. We're going to begin a transaction, and we are going to run this update. Okay? We're not going to roll it back yet. We're just going to get that update going. And then we're going to run this query. And remember the last time we ran this query? This query took about 4 or 5 seconds. This time, it's going to take a lot longer than that. Why do you think? This query it starts with a B, blocked. That's right. This query is now blocked. But part of this query has run. The part of this query that went and started to scan the clustered index, it's done. It's done most of that work, but now it's stuck. Now we're going to come over to this window, and what we're going to do is run this update. This update is going to change all the post type IDs for the rows that we just selected to post type ID 1. What did we just look for in this query that I just suddenly somehow got dislodged? What did we look for in here? Stuff where post type ID equals 2. We just read a bunch of rows. All those rows had post type ID 2. Then that query got blocked. Then we changed those rows. Now look what happens when we commit this one. Or sorry, when we roll this one back. We're going to roll it back. We're going to undo this, adding a millisecond to this state. We no longer need to do this. What happens over here in the results that we get back is kind of awful and kind of shocking and kind of depressing. All of the post type IDs where we said, hey, SQL Server, give me all those things where post type ID equals 2, they have magically changed to post type ID equals 1. This is a side effect of read uncommitted. Or sorry, of read committed, the garbage isolation level. We're going to talk about read uncommitted a little bit later. This is a side effect of read committed, where you did read rows as they were committed at the time that you ran them, but by the time the query finished, they were something else. All right, crazy. How can data change, right? So the first thing I want everyone to know is that read committed, the garbage isolation level, is not a perfect snapshot point-in-time view of your data. It has very, very weak guarantees, and those guarantees are basically that whatever rows you read were committed at the time you read them. After you read them, anything can happen. It's not a good time. It's a bad situation. So that's the first thing, all right? Anyone have questions on that? No? All right, good, because I don't know if I have good answers. So, oops, I was supposed to do this one to roll that back. There we go. We are making steady progress. So in SQL Server, isolation levels essentially come in 2.5 flavors. Up at the top there are the 0.5s. If you ever want to start a weird DBA fight, ask them if read uncommitted is an optimistic or a pessimistic isolation level. It's a weird thing to think about. What is it? It kind of does whatever it wants. So we have read uncommitted, which is a synonym for no-lock, right? They're not different things. They are the same thing. There is technically an isolation level called chaos, which the lovely and talented Jake Mansky showed me in a maintenance plant once, and I have been haunted by it ever since. SQL Server doesn't actually ever honor the chaos isolation level, but if you just want to freak someone out, you can change your index rebuild maintenance plan to use the chaos isolation level and see if they ever catch on to anything weird. Then SQL Server has some other isolation levels. And these isolation levels do some like weird locking with reads. These are pessimistic isolation levels. We have read committed, which is wimpy pessimistic, right? Is not very good guarantees with read committed. Then we have repeatable read, which is a little more pessimistic. It does some additional locking and some holding on to stuff. Then we have serializable, which is really, really pessimistic. This is where you usually start asking for trouble and deadlocks with like every single query that you run. The vast majority of applications that I see and look at don't need either repeatable read or serializable across the board. Repeatable read and serializable are fairly specialized isolation levels for very specific circumstances where you need a bunch of extra locking to guarantee consistent results. So let's look a little bit at what you can do or what you can't do with pessimistic isolation levels. We're going to create a brand new table called pessimism, right? It's probably not off to a very good start. What's wrong with this table? Oh, it's very, very pessimistic. And we're going to insert some rows in there. The only rows that we're inserting there are odd numbers. Right? 1, 3, 5, 7, 9. I am a high school dropout, but I have been assured by reasonable people across the world that 1, 3, 5, 7, and 9 are odd numbers. All right? We can at least be fairly sure of that. What else? I don't know. All right, now I got to put a bunch of this stuff into a new window, down to where I made a helpful note to myself to say stop scrolling and copy this into a new window, because otherwise I would probably just scroll forever and no one would forgive me. All right. So over in this window, we have some queries that are going to run, and they're going to update some data, and they're going to insert some data. And, well, actually, no, they're just going to update some data and delete some data. Up here, I'm going to show you something else. Don't worry, it's great. So what I'm going to do is down here, I'm going to begin a transaction, and I'm going to select everything from the pessimism table with repeatable read, and I'm going to throw a a row lock hint in there just for some extra spice. So here we go. All right, you're prepared to be wowed and amazed and feel fantastic about everything. It returns the first 4 rows of odd numbers that I put in there. Right, we're off to a good start. We have reliably odd numbers. We have the results we want. This query feels great to me. Now what we're going to do is the first thing that I want to show you is that repeatable read does lock the keys of the rows that it touches. The thing that's a little hard to explain about repeatable read, though, is that it doesn't look forward to lock rows. Serializable kind of does that. But repeatable read only locks the rows that it cares about as it reads them. So repeatable read can actually kind of fall behind some stuff. Repeatable read is kind of weird. But the cool thing about repeatable read is that it does lock rows in a way that things can't change underneath it. Well, some things can. This thing can't. So if I try to update a row that is currently locked by that repeatable read select, this update is just going to get stuck forever. So if I try to update the ID 1 after not using the right database and getting in there, now we're all set. If I try to update the ID 1, this update query will get blocked forever and ever. Right? Kind of a bad situation for the update query, but a great situation for our repeatable read query because it is going to honor its own locking semantics, something that I'm told by very smart people is an important factor in databases. Locking semantics, reliable code, stuff like that. Someday SQL Server will have all these things. I can't wait. I'm excited for the day. The future is bright. What's weird about repeatable read, though, is that you can do all sorts of stuff to rows in between the ones that you have locked, which is a little strange because it doesn't feel like those reads would be very repeatable if you stick a bunch of stuff between the rows you read. So like in the other window over there, I just said where the IDs are less than or equal to 7. But if we repeat those reads with repeatable read, I can still do stuff to values in between that. And it's kind of unpleasant. So for example, I could insert all the even numbers that I wanted in between those rows. That completes successfully. Repeatable read didn't lock the numbers between what I read. It just locked the numbers that I read. So if I go and look at what's in that table now, I have oh, wow, cool, it changed to the text results. That's handy. That's always a fun thing. So we can do that with repeatable read. And you can also move keys around with repeatable read. So if I stick, excuse you. So let's look at what's in the table. All right, we have this, 13579. I can update ID 9 to be ID 2, and then this will disappear here. And then I can also delete that row out from the table. And the whole time, this thing has a transaction open, and I'm just doing things to numbers in between where it was doing things. So repeatable read doesn't exactly guarantee you all the stuff that you would think it does, because we can still do all sorts of strange things to values in between what we read. So if we were to actually run this query twice in a row, we would just see all sorts of weird stuff in the table. So it's kind of weird. Serializable does a bit more, right? So serializable does help us a bit more than repeatable read does. So for example, if I stick this stuff in this window, and I'm going to try to find page up, and I'm going to not be able to find page up because I never use my laptop as a laptop. I always have it plugged in to something else. Make sure we're in the right database this time, not fudge anything up. So where serializable is kind of interesting is it does lock all the rows that it saw, and it locks the key values in between the rows that it saw, but it'll also lock like a row ahead of whatever we look at. So if we come over here and let's just make sure nothing weird is going on, because sometimes weird things happen with these isolation levels. What I'm going to do is open a transaction, and I'm going to select everything in the pessimism table where the ID is less than or equal to 5. Right? Big fun stuff, very complicated queries here. Everyone's shocked and amazed that I can hang on to this. But if I run this part, right, and I say begin transaction, insert into pessimism, even because I said where we're less than or equal to 5 up here, serializable locks 1 ahead. So I can't put that 6 in there. What I can do is I can quote out the 6, because this query got blocked. We don't really have anything cool going on. And you know what's really funny about SSMS is if you begin it, and this, I've learned this the hard way, like 15,000 times at this point. If you begin a transaction and then you cancel the query, it doesn't do anything with the transaction. The transaction's still just out there holding on for dear life, like, yeah, I'm here. And then like you'll do a bunch of other stuff in the window, and then you're like, oh, cool, I got all this stuff. It's all set. Everything looks good. And then you hit like rollback, and you're like, everything is gone now. Where did it go? I don't know. Just disappeared. No longer wanted to be part of this world. But I can run this insert, and I can insert rows beyond that, right? So now we have this stuff in the table. So serializable does a little bit more work than repeatable read does, which I guess is great for serializable. The serializable is kind of a harsh mistress aside from that. Most of the people who I see using serializable are using it by accident. If you are an Entity Framework C# developer and you use transaction scope, you are by accident using serializable as your isolation level, because it just bumps it right on up to that, doesn't tell you anything, and it just leaves you to sit there and hate yourself for causing all sorts of problems. We could avoid the look-ahead locking type thing if we rewrote the query like this in 2 parts, but who has time for that? Right? I see the way all of you write queries. You don't have time for much. Right? Not a lot of thought going into those things. So the funny thing about serializable is that like the way that it's set up, it's like all your queries are running like as if they were running by themselves. But what we don't know about our queries when they're running is how they like kind of got scheduled and all that mess. All we know is that when these transactions, when your serializable queries finish, the only thing that's guaranteed is that the results were serializable as of the time your query finished. Not when it started, not at the beginning, only at the end, which is kind of weird. But it does provide a consistent snapshot view of data as of the time it commits. It just doesn't guarantee anything beyond that. You don't know the logical order that your transaction happened in amongst all the other concurrent transactions, right? You have no idea where, when that, how that thing got scheduled. Serializable is a very, very tricky thing to get right. So let's switch gears a little bit, and we're going to talk about why I love no-lock. Right? There are some very obvious reasons why I love no-lock. Right? So I am a consultant, as I've mentioned. Very reasonable rates, again, right? Make sure. And when I see lots of no-lock hints, it guarantees a few things, mainly money. way more of it. It means your developers need a lot of training. It means your queries and indexes are probably god-awful. And it means there are probably some really, really bad bugs in the software that you just haven't caught on to yet. No one with lots of no-lock hints in their queries is happy with the way things are going. And look, and this is one of those thoughts that came to me like as I was waking up one day. And so now you're all going to get to enjoy it. The problem isn't no-lock. Everyone likes to write blog posts, right? Everyone who blogs about SQL Server, you don't see this in other database platforms because every other database platform in the world, maybe not everyone, but the ones that matter, every single other one in the world, like they got it right. They use multi-version concurrency control out of the box. That's a funny, just long-winded academic way of saying optimistic isolation level. Actually, they're probably about equal in that. But every other one does it. When you read blog posts about other databases, there is not a single shred of time spent talking about read uncommitted and no-lock and all this other stuff. Not the way it happens in SQL Server. But the problem isn't no-lock. The problem is read committed. If people were happy with read committed, they wouldn't be running to no-lock. No-lock is not the problem. Read committed is the problem. Right? It's a baffling thing. Read committed is such a bad isolation level that people are like, screw it, we can just return wrong results, tell people to run queries again, just whatever. Anything but read committed. Why is it the thing? Like, why is it still a thing? Why does it exist? The only other time that I make as much money from consulting clients is when they have a lot of no-lock hints, is when I hear these words. We're an entity framework only shop. My wife has nothing to do with tech, nothing at all, right? But she knows when I text her, no-lock or entity framework, she can start shopping. You can actually see my credit score go down in real time when I text her these words. It's like a browser window opens up and the credit score goes down. It's like Credit Karma is just like tracking me. It's just like, it's amazing. But the thing that's still baffling to me about no-lock after all these years is that people just don't know what it does, right? They're like, oh, it just keeps my query from taking locks. Everyone sitting in this room knows it doesn't keep your query from taking all the locks. It means your query ignores locks taken by other queries. So we're going to switch gears a little bit here. These are things that you can see under read committed, right? So this is, oops, that didn't go well. Wow, thank you, Zoom. You are doing me well today. These are things that you can see under read committed, right? I'm going to circle, or I'm going to rectangle that for you, right? This is read committed. This is the default isolation level. We're not at read uncommitted yet. You can see the same row twice with the same values. You can see the same row twice with different values. You can miss rows entirely, and you can duplicate rows entirely. This is all read committed. This is what people are abandoning for read uncommitted most of the time. One thing that's really, really funny to me, and like looking around the conference this year, half of the, well, not half, but like a good portion of the conference is Postgres material. And a good portion of the people in the world who run SQL Server are like, oh, we're moving it to Postgres. It'll be done in 6 to 6,000 months. We're not sure. Somewhere in that window, we'll have a full thing migrated. One of my longest running clients is like 3.5 years now. When we first started talking, they were like, yeah, in 8 months, everything's going to be Postgres. And I was like, great. Should I send you Christmas cards? 'Cause what are your kids' names? We're going to be around for a while. But everyone, a lot of people were just like, oh, I can't wait to get this moved to Postgres. I'm like, oh, well, cool. What are you looking forward to? And they're like, oh, it's free, it's cheap, like SQL Server licensing, blah, blah, blah. And I'm like, yeah, well, why don't we talk about your SQL Server problems? You got a lot of locking and blocking. Why don't we use RCSI? And they're like, oh, we can't use an optimistic isolation level. It's all dirty reads. And I'm like, huh, you're going to have a good time when you get to Postgres then. Out of the box, it does that same thing. Arguably, Postgres has the worst implementation of optimistic isolation levels because they do all their versioning in the table, right? That's why everyone who uses Postgres is really just neurotic about vacuuming and cleaning things. So it's a real funny situation. They're like, I hate heaps and optimistic isolation levels, but I love Postgres. And I'm like, you are in the wrong relationship. You read the wrong dating profile. Bail on that. Swipe the other way. So this is read committed, right? This is the bad of read committed. Read uncommitted adds all those problems, plus dirty reads from uncommitted transactions, partially committed row and column data, and data movement errors. If you are the type of SQL Server menace who looks through the error logs, you might have seen one of these multilingual errors before in your life, right? But the one that I understand is this one. Could not continue scan with no lock due to data movement. Oh no. Queries can fail with this error if you are no-locking too much. That's not a very good time. No-lock, lots of bad stuff in there, but again, no-lock isn't the problem. Read committed is the problem. People are willing to deal with this rather than read committed. It's amazing. But let's talk about something a little more serious. All right, don't get solemn, but like this, this grim here. Most everyone associates like dirty reads and no-lock with like select queries, right? You run a reporting query using your no-lock hints. Your data might be a little off here and there. It might, you might have been expecting pickles, but you got like pickled eggs instead, or who knows, right? That's like goofy stuff. But whenever you see people use a lot of no-lock hints, those no-lock hints tend to sneak into every single portion of the code. One of my earliest jobs, there was actually like developers got SQL prompt installed, and they're like the SQL prompt profile that everyone got installed by default had a hotkey to insert with no lock. So with no lock ended up everywhere, and that's again, that's not a SQL prompt problem, that's a company problem, but whatever. So like SQL prompt's great, I love it. Thank you, Redgate, but. Sometimes you can do bad things. You can do bad things with any tool, right? It's not a good time. So what a lot of people don't think about is that using no-lock in queries can actually write bad data to your database and tables and everything, right? So let's look at an example of that. We are going to use this fabulous, and we're not going to collapse queries. Come on, buddy, work with me here. We're going to look at an example of how no-lock can persist bad data in your database, and good luck finding it, right? Good luck figuring this out later. So we're going to stick one row into this table, and we're going to stick one row into this table, and then we are going to use my super powerful second window, because once again, I am the Flash. Oh, we should take the rollback with us, shouldn't we? That's probably a good idea. That seems like a reasonable, responsible thing to do, is keep that rollback with us. Well, we might need it later. All right, so over in this window, we have an update, and this update statement has a no-lock hint in it on the other table, right? So what this means is we're going to update the table called no. It is aliased as n, and that's the only table that's going to have a lock taken on it. The lock table has no locks, and it has a no-lock hint. So when we read from that table, we can read data from uncommitted transactions. Let us pretend for a moment that this is like a bank account balance, okay? Stick with me on this. Let's come over to this window, and let's begin a transaction. Well, let's make sure we're in the right database so that we don't embarrass ourselves further. Now, we're going to begin a transaction, and we're going to start to update the lock table, and we're going to use the integer maximum value as the result of our update. All right, here we go. Begin tran, update, cool. Everything going well, everyone's happy. Maybe the person who started to enter that into your bank account balance line, I don't know, maybe they picked up a phone call, or they got a notification, or they just got distracted by a TikToks or whatever, and they kind of looked away for a moment. Now we're going to run this update query. You know what we're doing with the update queries, we're going to use this magical output clause, all right? And I'm going to show you exactly what values end up in the table when we run the update. And because we have a no-lock hint on the lock table, we actually would end up committing the integer maximum into one of our user tables. Now, if I were a bank user, let's say I had a bank account and I wasn't just stashing my money under a mattress because I don't like paying taxes or something, like some crazy man in the mountains type thing. Let's say I had a legitimate grown-up bank account, and one day I opened up my bank account and I saw that number as the account balance. I would, of course, run to the bank. I would try to withdraw as much of that as I possibly could, but I would also want to close the account because I knew that the only way I'm ever going to have that much money in a bank account is if someone screwed up royally. Usually, I would blame no-lock. I don't know about you, but that would terrify me if I saw that. I would probably run away screaming. So as you're sitting there writing your queries and festooning them with no-lock hints, hither and yon, be very careful where you use them, especially if you're using them in modification queries, because your modification queries can actually end up writing no-locked data or deleting data they shouldn't, or doing all sorts of awful things and persisting that in your database. And you will have a really hard time figuring out who, what, where, when, and why made that change and put that bad data in there. You will blame all sorts of things. You will have application developers running around looking for bugs. Their heads will be on fire. They will be so very angry and upset. But really, it's just no-lock's problem. But really, no-lock isn't the problem. Read committed is the problem. People are willing to do this rather than deal with read committed. It is really a bad, pitiful thing. Are there any questions so far? Does anyone? I mean, I know we're live streaming, and it might be a little bit more embarrassing than usual to ask questions, or a little bit more fraught with peril and whatnot. But anyone? No? All right, cool. We can keep going then. All right, let's roll this thing back so we don't end up with anything weird happening. So the no-lock hint in the update query was no-locking a table that was currently locked by something else. It ignored those locks. We wrote a number to our database that we shouldn't. Now, let's go back in time a little bit. Microsoft, as far as I'm concerned, even though I'm not a Microsoft employee, it just says it on the arm of the shirt. Microsoft kind of really screwed up a long time ago. They introduced read committed snapshot isolation and snapshot isolation. And they could have just said, look, if you create any new databases, read committed snapshot isolation is going to be the default. But they didn't. Instead, we got decades of posts scaring you about marble colors and TempDB and all sorts of other things, long-running transactions. They did their best to like petrify everyone so they didn't use optimistic isolation levels. And then a really cute trick that they played was when they made Azure SQL DB. And they were like, we're going to manage your workloads. Give us your SQL servers. People were like, cool, here they are. And Microsoft was like, we're going to use RCSI by default now. So you use Azure SQL DB, read committed snapshot isolation is the default. Microsoft's like, I don't want to deal with all this blocking and deadlocking. What are you, insane? You people crazy with this? Like, who would want to deal with this? So when they came to them and like them dealing with your workloads, they were like, great, RCSI, it's the wave of the future from 2005. All of you, though, you just get the scary blog posts about like, whatever wrong data stuff people go on about. So multi-version concurrency control is the default like everywhere. Even like evil Oracle, they use multi-version concurrency control out of the box too. So like you can talk a lot of stuff about Oracle, but at least with them, you don't have like 10 billion blog posts about no-lock hints, and you don't have readers and writers blocking each other. They just were like, yeah, this seems like a good thing to do. There's a reason, I guess, Larry has an island, and I don't know. I don't know what Satya owns. I don't follow him that closely. We stopped talking a few years ago. He got too popular for me. I don't know. It's kind of whatever. But not SQL Server. SQL Server is pessimistic by default. And the isolation level that it uses, which is pessimistic by default, still doesn't have very strong guarantees. Basically, about the only thing that it guarantees, the two things that it guarantees is, one, you have only read committed data. Great, okay, well, that seems okay to me. But it also guarantees that your read queries and write queries are going to suffer from the stupidest blocking and deadlocking problems that you will ever come across in the world of databases. Most people, when you try to convince them to use an optimistic isolation level, they all of a sudden read a blog post and become just like indelible experts on the matter. And they start talking to you about race conditions, and they start talking to you about like phantom reads and all sorts of other things. And you're like, well, I guess read committed too, that's the one you're using. They're like, yeah, but this other thing. And I'm like, no, it's definitely just that thing. And then I'm like, also, all of your queries have no-lock hints anyway, so like, what are we losing here? Like, you're not really going to get anything messed up. Blocking between read queries and write queries and deadlocking between read queries and write queries is just an inherently stupid and boring thing to have to troubleshoot over and over and over again. If you find yourself having to do that, An optimistic isolation level can solve vast swaths of your problems without you having to nitpick every single query and index and start worrying about foreign keys and cascading things and indexed views and triggers and this, that, and the other thing. You can really fix a whole lot of stuff all at once just by switching that over. So when I said that there were 2.5 isolation levels, we talked about 1.5 of them. This is the last one of the 2.5. You have read-committed snapshot isolation, which I lovingly refer to as RCSI, and then you have snapshot isolation, which I lovingly refer to as SI. It's not the Sports Illustrated swimsuit issue, it is snapshot isolation. Under RCSI and SI, read queries and write queries don't fight with each other. Read-committed snapshot isolation, you can think of that as opt-out. What that means is that when you turn it on for a database, every single read query that comes in will start using versioned rows when they are locked. When you have snapshot isolation, that is more like opt-in. You have to specifically ask your queries to use that isolation level in order for them to do it. You have to stay awake too. You don't get a pass because you're not Ireland. I see you down there. There are some things that optimistic isolation levels don't fix. They don't fix all reader and writer blocking. Foreign key validation, foreign key cascades, and some index view maintenance will also be blocked under that because, I don't know, SQL Server is a database, and it's a database, so you got to do ACID or whatever it is. So there are some things that are not fun in there. So let's look at a case where people would normally worry about race conditions and other bad things happening under an optimistic isolation level that really are actually better than what happens under a pessimistic isolation level. So we're going to create two tables called 1 and 2. I can count, even though I am a high school dropout. It is fine. You're in good hands. And we're going to put some data into those tables. It's not very interesting data, I promise you, but that's okay. This is what the data in the tables currently look like right now. We have the IDs 1 through 10, and we have this all total column, which is just the number currently 110, 110. Right? All good there. Nothing really weird. What we're going to do is we're going to run this update in a loop. And thankfully, because with this query, we don't have to worry about rolling anything back because this is a garbage table that I just dump anyway, we can just let it roll. All right? So let's make sure that we have the right query highlighted down here. So the first way that I'm going to run this is I'm going to stick a read committed. Remember, I just turned on read committed snapshot isolation for this database. I'm going to add a read committed lock hint to this query so that this query obeys the laws of read committed locking. Okay, so that's what this thing is going to do. So we can see this thing returns the same results as before. Now let's start running this update in a loop, all right? It's going to be fun, I promise you. I wouldn't lie to you about these things. There are lots of things I would lie to you about, all right? But if we run this query a few times, you might notice something a little funny. Well, that font is small, I'm sorry. You might notice something a little bit funny about this column, and that's that nearly every row returns a slightly different number over here, right? That's because even though read committed is only reading currently committed values, that update is still just banging away updating other stuff. So sometimes this query might get stuck for a second and see some other stuff down here. It might see something that got updated here and then read down here, and it might get to down here and get blocked. And there's just all sorts of stuff about read committed that makes these numbers look all sorts of funky and funny. If we quote out this read committed lock hint and we say, hey, query, you are officially allowed to use versioned rows under this optimistic isolation level. Every single time we run this, we will get a stable set of values back from this. So if you're like me and you end up arguing with a lot of people about isolation levels, this is one of those kind of fun things that you can say, no, trust me, you're going to want that snapshot. You're not going to want that read committed. You're using the no lock to get away from the read committed. Read committed snapshot isolation is a better version of what you're doing. Are there any questions on that? No? All right, cool. I guess you all read that blog post too, and you are also isolation level experts. This is good news. Everything you know about isolation levels is right. We're just confirming each other right now. It's wonderful. This is a nice affirmative session. We are just you and I talking together about how great optimistic isolation levels are. So in this demo, the read committed version of the query saw inconsistent results as it was reading through the table. We saw values being incremented all around the things that we were doing. Under read committed snapshot isolation, we read a snapshot of those rows, and we did not have those same inconsistent results. It was a wonderful thing. So read committed is not so hot of an isolation level. In fact, it kind of stinks. In fact, it kind of stinks so bad that people use no-lock hints all over the world. People use no-lock hints across the world so much that we have that no-lock, that error message about data movement making up our no-lock hint query break in every single language that SQL Server supports. It might not be representative of every language in the world, but it's a fair number of them, and they're probably translatable, or there's some local dialect or something that you could probably make do. Read committed does not give you a point-in-time view of your data. So one thing that's really important to understand about databases and database workloads and concurrency and all those other crazy things that people who do our jobs have to think about is that there's really no such thing as a perfect isolation level for every single query, right? Like, a lot of them will function generally better under an optimistic isolation level, but there are some that you're not gonna, like some that just don't. There are some that do require locking, or might require read committed or repeatable read, or even serializable in order to get you the consistent results that you want out of them. The way I like to think about it is this. Almost everyone in the room at some point in their life has probably installed a SQL Server, and you've probably either had a guide that you follow for setting things up, or you probably I don't know, maybe you just have magic numbers that you make up and you like sort of chaos monkey it, and you're like max stop 3.5, cost threshold 4 billion, right? Just whatever goofy thing you feel like doing. But when you install SQL Server and you make changes to settings, like you do the consultant thing and set max stop to 8 and cost threshold for parallelism to 50, and you're like, this is probably good enough, just go forth into the world. You're setting a reasonable set of guardrails for your workload, right? For your queries to run under. This is probably a reasonably good way for your queries to run. Isolation levels are sort of the same way. You set up an optimistic isolation level, and most of your queries are going to run just fine under it. There might be some queries that you need to add hints to or change in certain ways so that they behave the way you want them to. It's sort of like the parallelism settings. There are some queries that might run better at max stop 16. There are some queries that might run better at max stop 7. There are some queries that should go parallel, but don't go parallel because cost threshold for parallelism was set to 50 and your query had a query bucks cost of 37.2. You just missed. The point is that most things run reasonably well with those guardrails in place. You have to figure out which of those tiny little things or which of those queries need to run differently, right? If you're tuning a query, you might throw an index hint on there, right? Maybe the optimizer picked a weird index. Maybe that index is great for lots of other queries. It's just not great for this one, right? These are things that we do as performance tuners, as DBAs, developers, things like that, where we have to find these queries that are misbehaving and apply things to them so they behave. Most of the time, when you want your queries to behave really well in a highly concurrent workload, an optimistic isolation level is going to be fantastic. There might be some that don't, and those are the ones that you have to find. This is what you get paid for, remember? You don't just take the backups and restore the backups and do the check DB, right? You do much smarter things than that. This is the beauty of optimistic isolation levels is it takes so much crap off your plate that would be awful for you to sit there and troubleshoot and bug fix and work through. It's up to you to find the queries that aren't that great, that don't function that great under them, and make those changes there. So let's talk about the perils of read committed. And we are going to go hardcore into flash mode here. My pants are staying on, but remember the flash, not a flasher, okay? So keep that in mind. Some of you are wrong in your heads, I can tell looking at you. The way that your eyes lit up when I said hardcore flash, it was nightmares tonight. So this is a handy chart of isolation levels and things that can happen under them. What I want you to pay close attention to, at least right now, is those sort of second two down, read committed and read committed snapshot isolation. Notice that neither one of them allow dirty reads. Right? We have a big no here. But both of them can allow non-repeatable reads and phantom reads. We'll talk more about how read committed snapshot isolation and snapshot isolation differ in a second. But what I want to show you is just how awful things can get under read committed. So let's do a little bit of preamble stuff here. Make sure we're in the right database. Let's drop a table just in case, because we like to live on the edge. And while I create this table, I want you to pay very, very close attention to this column in the middle, the one that has all the stuff that says pay attention to this around it. This column is defined as unique, which means it does not allow duplicates, right? Unique, no dupes. That is a unique constraint. It is backed by an index. That index will yell at us if we put any duplicate values in there, all right? This is a very important part of the demo. This is something everyone has to understand very deeply, incredibly deeply. So let's put some data in there. And these are actual factual New York City brunch menu prices. I don't know if you've ever been to New York City. It's out of control. I remember one day waking up and going to brunch and looking at a menu and thinking, $18 eggs. All right. like two of them. Like, it's nuts. Anyway, these are not actually how I value brunch menu items. Clearly, steak frites would be much, much higher at the top there. But anyway, this is how the table currently looks. Right? We have some nice rows in there. It's basically everything that I just showed you, but in table form rather than insert form. And this doesn't really take a lot of explanation. Just note that the last activity column is null, and we have a unique set of account IDs in these results. So everything is right with the world here. Everything feels great. So we're going to put this query into a new window. And when this query is in a new window, we are going to do a slight alteration to it because I have to unquote this Go because this thing caused all sorts of problems when I tried to use SQL prompt to insert semicolons. My $75 a year semicolon inserter. And what the Go2 does is it runs that query twice. Right? You put a number next to Go, and it'll run that query as many times as you put the number for. Right? And well, this is over here. You and I, this is where we turn into the Flash. All right? We are going to begin the transaction, and we are going to run an update. And that update is going to change some values, some column values in the table for ID 7. So right now, the mental picture you must have is that this update has run, and it has locked row 7, ID 7 of 10. Right? So row number 7 is locked. The rest of the rows in the table are completely free game. All right? Now we're going to come over here, and we are going to run this query with the Go2. Oh, but because I killed it, now it's getting weird on me. All right, we're good. The funny thing is, some errors in SQL, if you just rerun the query, it'll just reconnect and do it. It's wonderful. So this query is now blocked on row 7. While this select query is blocked on row 7, you and I are going to come over here, and we are officially the Flash. We are going to make some other changes to this table. We are going to update rows 1, 3, 4, and 9. And that runs smoothly. That runs successfully. We're going to update row 6, right? That's 6 is right before 7. I remember my last year of school, they taught me that. We're going to update row 10 because we haven't touched row 10 yet. Row 10 isn't blocked. Now we're going to delete rows 2, 5, and 8. Okay, these rows no longer exist in the table. Now we're going to insert some rows with completely different values, or rather values just kind of switched around and reversed, right? Because we had steak frites as 2 and French toast as 8, and now we've done something devious and we've switched them. Aren't we awful? Aren't we just crazy people? And now with all that done, we're going to commit this transaction. And when we come over here, we see some very, very strange results up in this table, don't we? We see what looks like, perhaps, maybe, where did my cursor go? There it is. Go away, you ding-dong. We see what looks like, what should be a unique constraint violation. We have 2 values, 1006, in our unique constraint column. Very strange. We now have, this is where it gets even weirder. We now have 2 steak frites with different values. We now have 2 Scotch eggs with different values. We are missing a whole bunch of stuff. We do not see where last activity changed for many things that it changed for. Read committed truly is a garbage isolation level. The results down at the bottom are how the table looked when this query finished. We are not having a good time. So remember, read committed, It's not a snapshot of your data. It does not protect your data in any way. All it guarantees is that when you saw something, nothing else wasn't being changed, right? It was fully committed data. Once you read it, anything can happen. It is a wild world out there. Are there any questions on that one? No? Erland, you look puzzled. Are you okay? You're good? All right. You know, you got people sitting next to you. I don't know if you want your arms up like that. It's a long flight. All right. So let's look at some of my least favorite situations with read committed, the garbage isolation level in SQL Server. The first thing I'm going to show you is that what most people think about when they think about blocking in SQL Server is, oh no, that darn developer ran a long-running update and they blocked all my select queries. True, they did that. They're awful. You should fire them. Show them the door. Or I don't know, just like fire the best developer to get all the other ones real worried. I don't know. This is why I'm not in management. A lot to be desired. But what can happen quite a bit is you can actually have read queries block write queries. I know. All right? It's just like, oh, great, it's going to get worse. Yeah, it's going to get worse before it gets better. All right, so let's switch back to my normal operating database, Stack Overflow 2013. And I'm going to create a procedure in here called, quite appropriately, read blocker. You can see where this is going. And with that out of the way, what we're going to do is we're going to run read blocker with, lovingly called Stack Overflow 2013. The world ended like Ghostbusters style at the stroke of midnight on January 1st, 2014. This is the end of the world for this copy of the Stack Overflow database. Probably some weird multiverse joke you can make in here. But if we run this and we look at the query plan, this is a very simple and reasonable query plan for the date value that we just looked at. Right? We do an index seek, we get a key lookup, we do a nested loops join to join our non-clustered index to our clustered index based on the clustered index key columns, and everything's great. Okay, that's fine. The trouble is, we have this thing called parameter sniffing. You may have heard of it. You may have heard of parameter sensitivity or all sorts of other things. You may even, Erland, wake up. You may even have heard of the parameter-sensitive plan optimization that got added in SQL Server 2022. That's probably not going to kick in here unless I did something really wrong. But this thing, when we run it, is going to reuse the same query plan that we just used before. The problem is, we are going to go back to when the calendar switched from, what was it, Julian to Gregorian or something? Maybe I have that backwards. But a fellow named Philip Stanhope was in charge of all that disaster. Good plan. I don't know what his deal was. He was an Earl or something. But this is what's gonna mess us all up. What we're gonna do is bring this. Oh, we should bring that rule back with us. We actually need that one this time. Don't tell anyone. What we're gonna do is we're going to come over here. And actually, let's make sure this is highlighted correctly because, we don't want anything weird to happen. We have enough weird things happen to us. We work in tech. And we're going to kick this query off, looking for 1753.0101. And this is going to run for a while. And if we come over and look at SP-Who is active, we're going to see something really terrible. Right? And this is something that I see quite a bit with clients. And those clients are not happy with the state of things in their database. You see that select query. What is that select query doing? Running, selecting stuff. We have that update query. What is that update query doing? Updating stuff. What is happening to that update query? Well, it is blocked by that select query. It is trying to take some intent exclusive locks, and it is unable to because that select query is blocking it. Why is that select query blocking it? Gosh, you asked the best questions. Thank you. You just lead me right into it. It's amazing. I couldn't ask for better folks here. So what happens is, and as soon as this thing starts cooperating, there we go. Oh, that was close. I have a very sensitive trackpad. Probably a side effect of me never using this thing. It actually is a laptop. But what happens is, let's go back to the original run of this query. When you have a key lookup, SQL Server has to do something real special. It has to protect data, right? When you read data out of that non-clustered index, like it's a nested loops join, so you do that one row at a time. SQL Server has to protect the data in the clustered index because that data can't change. What would happen if you found a row, like in your index seek, and you went to look that row up and that row wasn't there, or it moved, or it had been deleted, or someone had changed something about it that you didn't want to be changed, right? What if it changed a value and it no longer matched the lookup? You would be in for a very bad time, wouldn't you? Yes. So while a key lookup like this runs, SQL Server takes what's called an object-level shared lock on your clustered index. That object-level shared lock sounds nice and friendly, but it is actually incompatible with any other kind of lock. Like any exclusive lock that comes along, SQL Server is like, nope, you're out. That object-level shared lock, for as long as that query would run for, would block that update query from running. This is one of the many, many terrible things that can happen to you under read committed, the garbage isolation level. Are there any questions on that one? I see some puzzled looks in the audience, but I don't see any hands going up, which can only mean one thing. When I'm packing up, you're going to come up here and say, can I ask you a quick question? And no one else is going to benefit from your quick question. We're all just, yes, we're going to, yes, Erland.
I would suggest paying that flag girl, I guess, why you get that big lock is because of lock escalation.
Right, lock escalation. Normally, thank you, Perry, that's a very good point. Normally, when you have a read query, locks don't escalate, right? Because those locks get taken and released very quickly. But under certain circumstances, things like this prolong the duration of those read locks, and they escalate, right? That sound about accurate to you? Yeah, cool. I got a yeah from Erland. Pack it up, we're going home. Drinks are on me. That was like when Paul White said my post was accurate. I was like, stop. Oh, you leave. Security. I can tell you're not, you can know I'm not Brent. I'm not dressed expensively enough. Also, I'm young and handsome. Just kidding. You look great with the salt and pepper, mostly salt. All right, so if you thought that wasn't bad, if that was not depressing enough, all right, things are about to get worse for us. We're now going to see a read query deadlock with a write query under very, very similar circumstances. So we're going to take this and we're going to put this over in this window, and this one's going to have a bad time too. And this one does rely a little bit on very, very precise timing. Not for the queries running, but for when I get to SP who is active. That's really where the magic is in this one. We're just going to have to hope and pray that we get this one right. All right, so let's kick, oh, you sneaky devil. Let's kick this thing off. And this thing is, oh, you know what? We might crash SSMS here. Nope, we didn't. Good. Let's turn off query plans before we run that update in a while loop. See, so the joke that I made that Erin took offense to was that sometimes I have to keep 2 copies of SSMS open, because sometimes I have to use another copy of SSMS to kill a tab in the other SSMS. And like what I was like, that's a me problem. That's a me workflow problem. That's not me hating SSMS. So, sorry, Erin. I apologize. It's not your baby. It's my treatment of your baby. So with query plans now turned off, we're going to, let's actually make sure we have this one highlighted correctly so I don't screw anything up. We're going to come over here, we're going to run this, and oh, it deadlocked too quickly. Oh, now it's done. Oh, we messed it up. There we go. Well, you know what? I think the best we're going to do for this one is we're just going to get the error. We're not going to catch it in who is active. But look at this. With this update running in this silly loop, our read query got killed off by the deadlock monitor. And we'll zoom in on that in a second. I just want to do things that I shouldn't forget about. Here we go. Look at that. Our read query deadlocked with our write query. Now, this is what usually happens. So it might not be the end of the world. I mean, your end users who are trying to get their account info and do whatever, they're probably going to be kind of pissed that they have to keep running queries over and over again and getting these deadlock error messages that you don't handle and pass them back something friendlier like, hey, try again in a couple minutes, we're busy. You just throw transaction process ID back to them and they're like, what? That's not good. So yeah, under read committed, read queries and write queries can also deadlock with each other. Another just awful chain of events. And this does not happen under read committed snapshot isolation. I guess if we're going to say anything nice about no lock, it also doesn't happen under read committed. So, you know, I guess, yes, you win this one. I don't really have anything else on that. That's kind of depressing. But yeah, so queries with those funny little nested loops thing in them, it would be the exact same situation here as in the last demo. The select query is doing a key lookup, and it deadlocks with the update query, because the update query is trying to like lock stuff and change stuff in the indexes, and the read query is trying to read stuff from the indexes and object level shared lock stuff, and neither one of them end up in a happy, successful, fulfilling relationship. They are both in bad shape. They both need years of counseling. There's a lot of like just maybe sad trauma bonding going on. I don't know. It's bad for everybody. So let's talk a little bit about concurrency sensitivity, because a lot of the ledge that I have to talk people down from when we start talking about moving to an optimistic isolation level from a pessimistic one is they're like, well, but I read the blog post, and the blog post said that I can get bad data from RCSI. Sort of true. Like there is some, like, you know, there can be some staleness to the versions of rows that you're reading. We'll talk about that at the very end. I don't want you to think that RCSI is perfect, because like I said, no isolation level is perfect. But there are certain query patterns that, as you write them under read committed, or I mean really under almost any isolation level, can give you some weird results. Because a lot of people don't think about what happens while a query is running, or what happens between you getting some data and then you doing something with some data. So let's look at some stuff in here, like this. Let's say that you have a query that comes in, you declare some variable, and you set that variable equal to some value. As you read data from the users table, what are you reading? Read committed. Can that data change before, during, and after you reading it? Yes. You have another read of the users table, getting the max last access date. Can that change before, during, and after you reading it under read committed? Yes, absolutely. So you assign a value to that variable based on really woolly stuff, really fluffy guarantees there, not hard, strong guarantees. You could add in like a transaction and some crazy locking hints and probably do better, but then you're, you know, going to have a bad time for probably some other reasons. So in between you doing that and you doing something with whatever value you assign to that variable, what happens? All sorts of stuff can change. Your select query just finished. Then someone logged in and they messed up the last access, the max value for that. All sorts of weird stuff can happen. At this point, you might be sitting there and wondering to yourselves, how does anything work? And I'm going to tell you how it works in one word: barely. Hanging on for dear life. Not having a good time most of the time. Concurrency can make all of this stuff very weird. Temp tables. I love temp tables. Use them to death. Probably overuse them at times. Probably, you know, I don't know. I use a lot of temp tables though. Oh boy. But let's say that we take some data from this total score by users table. We read from that table twice. What happens on both times that we read from that table? We could get like stuff, again, data can change in, near, around, all about while these queries are running. Then you put that data into a temp table. What happens after it's in the temp table? Nothing. The temp table is not looking back at your base table data like, well, if anything changes, you let me know, because we're gonna make sure over here. No, it's just materialized up there. You don't get anything out of it. So by the time you go and do anything with the data in that temp table, stuff in your actual base tables could have changed, right? This is more concurrency sensitive stuff. Even if you just do a simple update, right? Like let's say that we take the temp table out of that equation and we just want to update that total score by user table. Only one instance of that table is ever going to get locked. That's the one that we update, right? So like this part of the query where we're doing that, we have the update with the handy little alias there. That's this. When we read data in this part, we don't have any sort of protection. Right? Data can change all around while these queries are running under read committed. It's a real bad time. So even just doing a simple update, only the last, like the update alias of that will get any locks taken on it. These things, they just read through the data and go on with their day. Merge is, of course, a total disaster. Can we get a round of applause for merge? Come on, let's put it together. Yeah. Merge, another good one. Yeah. My good Canadian friend, I don't know why I felt the need to preface that with his national origin. Michael J. Swart has great, wonderful blog posts about not only concurrency, but a lot of stuff about merge. Strange Canadian fetishes, I guess. But they're really, if you don't follow his blog, you should. He's fantastic and very smart and an excellent cartoonist to boot. So, if you're into cartoons. Okay, no one's into cartoons. All right, screw it. But merge is an absolute nightmare when it comes to concurrency and when it comes to locking, when it comes to blocking, because merge does this funny thing where it doesn't always change all the data all at once. You might have completely separate operators for an insert or an update or a delete. And as those things happen, unless you have a serializable hint on the target table that you're merging into, all sorts of weird stuff can go on. It's a real bad time with those. So let's get to some meaty stuff. Let's talk about, I don't know if anyone's prepared for this. Let's talk about the difference between snapshot isolation and read committed snapshot isolation. Now, just purely behaviorally speaking, I like snapshot isolation. I like the way snapshot isolation behaves a little bit better than read committed snapshot isolation. Because if you remember what we talked about a little bit earlier, there is a difference between read committed snapshot isolation and snapshot isolation, in that read committed snapshot isolation does allow non-repeatable reads and phantom reads, whereas snapshot isolation doesn't. So let me show you what that means. Right? This is another demo that requires 3 windows. You don't actually. This one isn't very flashy, but it's just as cool to see. Not many people get to see this sort of thing. So let's make sure we're all good here. And let's make us a table called snip snap. And let's insert one row into that table, all right? This is what that one row looks like. All right, we can see that stuff in here. We're having a great time, just a single row, nothing too crazy going on. I'm gonna set both RCSI and snapshot. Wow, that worked so quickly. Usually it doesn't go that well. That means something went wrong. Just warning you. Anything that goes that smoothly, I'm like, oh boy. Kendra, get my bottle. So what we're going to do is put this query into a new window. This is going to run under snapshot isolation, our snazzy snapshot isolation query. And this is going to run under read committed, which is going to sound a little funny to you because I have a hint at the top that explicitly says set transaction isolation level read committed. But I promise you, it's running under RCSI. I swear to God. I had to put that in there because as I was doing this, sometimes it got really confusing which one was the snapshot and which one wasn't. So little bit how the sausage is made there, probably more than you needed to know about how I make sausage. But now we're going to do something extra fun. We're going to run this query, and we're going to run this query, and then we're going to come over here and we're going to do an update and an insert. This thing finishes immediately because what are we doing? We're updating one row and we're inserting one row, right? Nothing very prolific happening here. But here's the difference between RCSI, or read committed snapshot isolation, and snapshot isolation. The query that runs under snapshot isolation, under read committed snapshot isolation, if we were to start a transaction, run a select query, wait 10 seconds, then run that same select query, here's what happens. We get back from the table the original value that we saw, right? So as this table did stuff, we got that one row back. But at the end, when that second query ran, we got slightly different results back. We saw what happened after the update and the insert ran, right? So that transaction didn't mean that we got consistent select results back from both queries before and after. If you look at the update time for these, right? Because one thing we did was update the times in there. The actual get date versus the time that got logged into the table has a little bit of a difference in it, doesn't it? Uh-oh, there. The snapshot isolation query gave us consistent results back. So when I say that something doesn't allow phantom reads or doesn't allow non-repeatable reads, this is what snapshot isolation does differently then read committed snapshot isolation. We saw when that transaction started, the select query ran, it read some row versions, and that set the row versions that the second query was going to run when it actually executed. So we didn't see the stuff that happened between those executions. We saw a consistent version of the data across both executions. Now I have one more demo left, I think, at least according to the SSMS file here, the wonderful SSMS file, if you're listening. There is the possibility of race conditions under RCSI. And I'm going to show you a very typical query pattern for when that can happen. So we're going to make a table here called dinner plans. And we're going to put some rows in our dinner plans table. And we're going to have to forgive some of our guests for dinner because they were supposed to come to pass this year, but then didn't. And now, for some reason, our dinner plans are strange. And we miss people. But here's what our table looks like. For some reason, no one wanted to sit next to Paul, I guess. I don't know, smells or something. But for some reason, seat number 1 is null, right? So seat number 1 is empty. People were just like, yeah, 2, 3, 4, 5, 6, much better numbers than 1. So seat number 1 is open and empty, right? Here's what happens. Let's make sure this is turned off. And we're going to put this same query into a new window twice, but we're going to change it slightly, which I know sounds crazy to you. At this point, you would believe anything. So for one version of this query, we are going to have a reverse of Eric try to get a seat at the table. And we're also going to have a forward version of Eric try to get a seat at the table, all right? All good there, I think, anyway. And let's come over here and make sure we have our reset query highlighted, because at some point, we're going to need to reset this data. So here's what happens. We have this query that runs, and it says, give me the top one seat at this table where is free equals 1, all right? We're going to run this. This is happening under read committed, right? We're going to run this, and oh, what happened to you? Oh, I didn't highlight more. Which probably means, let me just make sure that this thing is actually reset then, because who knows? So let's do this. Oh, that's cute. Okay, now we got it. Apparently you can't do that. No. Snapshot isolate. Oh, because I didn't turn. Set transaction isolation. Oh, thank you. Isolation level, read, committed. There we go. Sorry about that. Figures I'm live streaming it to the very end and then something goes weird. Story of my life. All right, so this runs, and it finds a seat at the table. And then this query over here is also going to try to run. But what's going to happen is this query is going to get blocked, right? That update is blocking the other query. All good there. Now, if we come over and we hit commit here, this query is going to tell us we saw no rows, right? Because the other update query blocked it and made sure that we couldn't find a seat at the table. Backwards Eric did not win. Backwards Eric had a bad time. Now, we're going to set read committed snapshot isolation on, and we're going to repeat that same thing, except I'm probably going to, oh wait, no, it worked. Whew. See, when it takes a long time, like, oh, it was so fast before, why? So let's repeat that same experiment after we reset the table. And now we set that back to null, right? We have nothing going on. Let's come over here, and we're going to begin a transaction. We're going to do our same update. We're going to come over here, and we're going to do that same update. But now we're going to come over here, and we're going to hit commit. And when we hit commit here, what happens over here is a little bit different. Now, backwards Eric has stolen my seat. So where optimistic isolation levels can sometimes mess you up is when you have queries that do things in multiple steps. If we had just written the update query to do a simple update top 1, where is free equals 1, do a thing, we wouldn't have this problem. But because we did it a little bit backwards and we had 2 steps to the query, the version of the query where the read happened read a version of the row where that seat was still free and it stole the seat from the other query, which is sort of a bummer when it comes to optimistic isolation levels, but these are the times when you can start. If you do this sort of thing, you can always add locking hints in to fix it. So anyway, I believe that I'm just about at time here. I believe my quitting time is 5 o'clock. So if there are any questions, I guess you can come up and ask me one quick question as I pack up my bags. But just for anyone who missed it at the beginning, this is how you get in touch with me. That's where you download the decks and demos. Thank you so much for coming. Enjoy your time at PASS. Thank you. I love you.